Someone asked me to predict the paper for 9MA001 or the A level for the June 2025. So there you go, I did. And here is the paper. Now let me tell you first that this is a compilation of 15 hard questions from all topics, inspired by the past papers. Now, it might not have the same pattern as the past papers. It might be more difficult even, but I have no idea because I tried my best to not have seen this paper prior to recording this video. As for the theme of my channel, again, I'm going to blind solve this paper without having seen it before. And I'm going to be timing myself again. And I'm going to mark this paper later on. So if you want to know the right answer, just stick around. I'm giving you this paper for free. All I ask is nothing more than just a subscribe from you guys. Now let's dive into the paper. So I'm going to hit the timer now. Okay, let's get started. Number one, given that fx is blah blah blah, where a is a constant, x minus 2 is a factor of fx, show that a squared minus 2a minus 8 equals 0. Alright, so that is just factor theorem. Yeah. So it's given you the factor of x minus 2. So when we substitute the critical value, which is 2, into the fx, we should get 0. So we do 0 equals 2 and sub 2 in here, minus a 2 squared plus a is an unknown, so we're going to keep it for now. And then let's see how that goes. So we expect to show what it needs there. 0 equals, so this is 16 minus 4a plus 2a squared minus 20 minus 12. Alright. So far so good. So 0 equals 2a squared, and that is just minus 4a, the a terms. And then the constant term, 16 minus 20 is minus 4, this is minus 16. And then if we simplify, we should get the right answer. I'm just going to simplify by 2 here. Yep, that is as required. 2 marks, part A. Part B, hence find the possible values of a, okay? Yeah, we can factorize a minus 4 and a plus 2 here equals 0. Yeah, that works. And then a would be minus 2 or 4. Yeah, possible values. So we get 2 values there. And then C, for the largest possible value of a, solve completely the equation of fx. Alright, so largest possible value, which is 4 here. So we're going to sub 4 into the original function first. So 2x cubed minus 4x squared. So 4 subbing into a squared, we get 16. Minus 10 is 6, so that's just 6x minus 12. And then we're going to solve this, we're going to factorize this completely, or actually solve it, because we're going to put it to 0. And we know that one of the factors is already x minus 2, right? So you have a number of ways here. You can do a long division, or you can, just maybe assume that you're going to get a quadratic factor and then just work out the constants, right? I'm going to do a long division, right? So I'm going to take one of the factors there, which is already known to be x minus 2, and do a long division here to get another quadratic factor. Yeah? And then, so again, the first term dividing the first term, we get 2x squared. Yeah, proceeding. And then we multiply back, we get 2x cubed here, and that's the point because we want to cancel the first term. And this is minus 4x squared. Okay, so that cancels the 0. Subtract the 0. We pull the 6x down, and now we do the same thing again. Repeat. The first minus, divide into the first, we get 6 here. And that would be 6x minus 12. Okay, so if we pull everything down, they subtract the 0. So that is proving that this is indeed a factor. So what do we get here? If we solve that, if we factorize this again, we now know that it is just x minus 2 times 2x squared plus 6 equals 0. Okay, solve completely, right? It seems like they don't have a solution here. It's just one solution. So let me double check my work again, see if I got anything wrong there. 6x minus 12. Or it might be the AI's mistake. So yeah, put a 6 down, and then I think I'm fine with that, don't you think? Yeah, so I'm gonna go with this. So that means x is only minus 2. Sorry, 2. And nothing more, because the x squared plus x equals 0 has no real solution. Alright? Yeah? Because like x squared equals minus 3, not possible in real numbers. Yeah? I'm just gonna go with that, right? For the time being. And yeah, we'll mark the paper later anyway, so should be fine. I mean, in the authentic, like actual human-made question, this would have asked you, show that 2 is the only solution, maybe. It would have been that. All right? And this is just probably a flop again. I tried so hard to, you know, do like self-iteration to make sure that they come up with some valid questions, but okay, this should be the best one. All right. That's, I mean, the best that it can give you. All right. Number 2, find the first 4 terms in the ascending powers of x of the binomial expansion that, given each coefficient as a simplified fraction. All right. So part A, we have to expand that. That's not too bad. So we're going to expand up to the first 4 terms. So we do 1 because the first term is already 1, so that's convenient. And then plus n, which is minus a third, x, which is minus 3x, plus n times n minus 1 divided by 2 factorial minus, and then the second term squared, and then another term, right? So I'm just going to write down here maybe. Yeah. So the yeah, like that, divided by 3 factorial, and this is cubed. Okay. Checking everything. Yeah, that's all fine. Now I'm just gonna simplify each term. So this is 1. The 3 and the 3 cancel. We get plus x here, right? And then let's see. Okay, so probably a calculator will do a better job there. So let's see. Minus a third minus 4 over 3. So it's just plus that 1 over 3 times 4 over 3 on top there, and then times 9 because that is squared, so we don't have a negative here, then over 2. Well, that's just 2. Okay, nice. So plus 2x squared, right? Okay, and then the other term, I'm just gonna continue from here. So I'm gonna get another 3, so it's 7 over 3 there. Hang on. Yeah. And we'll deal with the minus sign later. Just get the number part first. And yeah, and then times 27 down there. Sorry, up there. And then this is 6. Ooh. Yeah, I need a fraction. Okay, now there is how many negatives? So that's 1 here, 2, 3, and then 3 here. So that's 6, so it's still a positive. So we put a positive here. Okay, that might be easier to do if you get the numbers first and then multiply them out and then deal with the negatives later. Okay, so it seems like I get all positive terms. And that is just it. Yeah? So part B. Given that x is small, use the expansion from part A, an expansion of 1 plus 1 over 2x to show that, okay, so they're mixing the thing now. Okay, that makes it harder, of course. Okay, so yeah, so we're gonna write that as this, of course, right? I'm just moving it up and the power will become a negative. which is the expansion we got earlier, which is this guy right here. Is initially this guy here and then this guy here. So it's like we are substituting this into this, right? And then what do we do next? We're gonna get the expansion of that to show that that is okay. So we're gonna expand this, right? So this is just basically 1 plus 1/2 x, and then all that. Yeah, and then you just expand. So we just want the x term and the x squared term. So the x and also the constant term, the number term. So it's just 1 times 1 here basically. So that's 1. And then we want the x squared term, but I'm just going to look at the x term first. So if I also do 1 times x here, I also get another x. If I also do a half x times 1 here, I get another half x, right? And that's probably it for the x term. The x squared term, we get it by 1 multiplying this. We get 2x squared. And then the other term is just a half x times x. So that's just half x squared. And that's simply it. Yeah? So we are expanding that all out. So we simplify. So this is 1 plus 3 over 2x plus 5 over 2x squared as required. That should be it, I think. Yeah, not too bad. Number 3. Okay, show that the equation 2/6 squared theta minus tan theta equals 5 can be written as that. Okay, that's not too bad. We just substitute the identity there because we know that 6 squared is 1 plus tan squared. Okay, so 2, 1 plus tan squared theta. Okay, yeah. Minus tan squared equals 5. Alright, so just expanding all out, we get 2 tan squared theta first. And then I'm just going to write minus tan theta here first. And then the 5 will subtract the left side, which will subtract the 2. And then we get minus 3 here as required. Okay, that's not bad. That's just easy. Hence, solve for 0 to pi the equation that. Okay, so we don't have to modify the range here. It's just theta and theta here. So I'm just going to go with that already. But first, let me factorize this guy first. Okay, so I would like to do it in this way. I don't need to substitute that to any other variable there. You can just look at it as a single variable, but when you write tan theta. So we have a 2 and a 1 here for the first 2 terms there in the brackets. And then how do you make minus 3? Well, it's just 3 and 1, right? 3 and minus 1. So if I put 3 here and 1 here, 3 and 2 will subtract to 1. We just figure out the sign. So the negative should go to the 3 because it's more than the 2 times 1 here. Okay? Those of you who are very good at factorizing the quadratic will understand what I say here. Okay. So that's pretty much it for this. Let me just double check that. I'm very careful. Yep. And then we split into 2 cases. Tan theta equals 3 over 2 or tan theta equals minus 1. Alright. And then you just do your thing, a cast diagram, right? I prefer a cast diagram because it's, yeah, I prefer it. So you guys prefer whatever method you use them. Yeah. So I'm just going to do the principal angle first. So I'm going to do arctan 3 over 2. And this will be what? Arctan 3 over 2. We're doing it in radian. So that's already in radian. Very important, guys. 3 over 2. So what do I get there? I get 0.982794. Just going to round up to 6 decimal places there. And then, okay, let's deal with 1 root at a time. So that's one of them. And then we need from 0 to 2 pi. So this is a positive tan. So we look at the first and the third quadrant for the tan. Okay, so we need this angle here, which is already the principal angle. Yeah, and also this angle right here. Okay, just sweep anti-clockwise there to make the theta positive. So that would be pi plus the principal angle, right? Like that. Okay, so, well, that's it, right? We already got the roots because that's what we need there. Okay, so we simplify that, so that works out to be 0.98. How many decimal places? It doesn't say. Well, my sense tells me that we should just give 3 significant figures. Okay, and then this will add pi to see what happened. 4.12 maybe. So I'm just going to brackets here 3 sig figs, right? Yeah, all right. And then the other one, well, we know that arctan 1 is like pi over 4. Yeah? Tan 45 degrees is 1. So that's pi over 4. And we know that this is a negative tan, so I have to go like that. So I want this angle here and this angle here. Okay, so theta equals, that is pi minus pi over 4 for the first one in a second quadrant. So it's 3 over 4 pi, right? And the other one is 2 pi minus. Yeah, you can also do 2 pi minus that principal angle. So 2 pi minus pi over 4, that would be 7 over 4 pi, right? Okay. I need to look in front of my house as well because it might be raining. Yeah. So it's 2 pi, 8 pi over 4. Yeah. Okay, I'm happy with that. So those are my answers. Just to write them down like this. I mean, I probably don't care much about... okay, I'm going to give them into 3 significant figures. So 3 over 4 pi, that is 2.36, and then the other one, 7 over 4 times pi would be 5.50. That's all my answer there. All right. Okay, number 4. Use differentiation from first principles to show that the derivative of that is that. Wow. Okay, haven't quite seen it do this. Yeah, I mean the past paper. Maybe inspired by the June 2020. You can check 2022, I mean, sorry. If you want, you can check that. So, the differentiation by first principle is just the limit of h going to 0 of fx plus h minus fx divided by h. Let me just... Okay. So we're going to plug in according to the formula there. I'm going to leave the limit of h going to 0 for now because we're going to write it every line. The fx plus h is basically substituting x plus h into the x. So we get that, right, for the first term. And then minus the normal one, the x, or 1 over x plus 2, and all divided by just h. Just that. And the rest is just algebra. So you got to be careful in your steps, right? So here we have what? If you do cross multiplying. Now, I prefer to maybe rearrange this a little bit so that it becomes that. So I can, you know, sort of like group this together. Okay, so now we can do the cross multiplying to make denominator the same. So that's x plus 2 minus x plus 2 plus h. Yeah. And this is big brackets here and all divided by just, you know, it's like you are multiplying these two terms, but then when you do that, this will expand to that and this will expand to h, right? So actually we have x plus 2 squared plus h, x plus 2. Make sure you understand that, right? So I'm not going to just multiply them all out in one go. No, not yet, because we don't need to. I think we don't need to. Yeah. And now here the h will multiply into all of this. And then the top bit we get what? X plus 2 minus what? X minus 2 minus h, minus all of those basically. And then divided by h here. And then what? All that is left, x plus 2 squared plus h, x plus 2. Just write them down first, yeah? So these all cancel, right? And we are only left with the h here, a negative h. So they cancel here with the bottom one. So we have what? A minus 1 on top. That seems like what we are getting, because we want a minus 1 there. Yeah. The bottom bit, oh, I already canceled the, yeah, okay, already goes away. So we only have 8x plus 2 squared plus h x plus 2. And now you know that when you cannot simplify any further, the limit of h going to 0 will come into play. So we're going to copy that first. I mean, you can't do this in the real condition, but I'm just going to take the liberty of using that feature, if you don't mind. Okay, there you go. So this is just minus 1 over. You're just substituting 0 to h. You only get that. Yeah? Sub h equals 0 here. And that is as a required. That's it. I'm just going to write a conclusion here. Yeah? Good. So that's not too bad. Next, number 5. The circle C1 has an equation of that. Find the center and the radius of C1. All right, that's not too bad. So usually we do this by just splitting. I mean, I prefer it this way. So we split the types of term into x and y. So this is the first line, not changing anything. But I move the minus 12 to the right side, become 12, like that. Yeah? And now you think how you add some terms so that the x group and the y group become a complete square. Well, if you don't know much of how to do that quickly, I have a trick to just divide this by 2 and square it. So divide the second term by 2, which is minus 6 over 2. So you get minus 3. So that would become, and then you square it, then you get 9. So just to write it first, this is a 9. But when you add a 9 there, you should add on both sides. Otherwise, you would change the problem completely, which is not what we want, right? So I already got the first square there. The second square, we do the same. So the middle term divided by 2, we get a 2. And we square that, we get a 4. But we need to add a 4 on the right side as well, like that. So the first square is actually x minus 3. It's just the thing we get after dividing the middle term by 2. And then this is also y plus 2 squared equals, what's that? 25. Oh, what a nice number. Okay, so that's it. So the center is 3 minus 2. Just getting the critical values there. And then the radius is 5, right? That's it. That's part A. Part B. Find the coordinates of P. Okay, the line L with equation y equals 3 is the tangent to C at point P. Okay, so we're going to visualize a little bit. So this is 3 minus 2, so it might be around here. Radius is 5, so it's going to go over the axis like that. Okay, but then it says the line y equals 3 is the tangent to C at point P. That's not so bad, actually. Is that sound, though? You have minus 2 here. Yeah, that makes sense. So this is 3, and this is 2. I don't know why it asked that. It's just we need to find the x coordinate of P, knowing that this is already 3, if you know what I mean. Because there is a line y equals 3 intersecting the circle there, touching the circle there. So we're just substituting y equals 3 into the function. Yeah? So what do we have? I'm just going to take the first line there. We have x squared plus y squared, which is 9, right? Minus 6x plus 4 times 3 is 12, minus 12 equals 0. Yeah, let's sub y equals 3 here. And then we get a quadratic, right? X squared minus 6x plus 9 equals 0. Okay. Yep. Am I happy with that? Let me check again, just in case. Yeah, I think I'm okay. So what is this? Isn't that just... Oh, wait, I should have done this. I should have known that this is just... It should be the same point as the center there. I mean, it should align with the center. So the x should just be 3, right? And if you solve this, of course, you get that, right? And then x equals 3. Yeah, I should have known. I should have known. Okay. Weird question. Let's do next part, C. A second circle C2 passes through the point P. And the center C1 and the center C2 lies on the line joining P. Okay. And the center of C1. Okay, that's a bit complicated. Okay, let's get that first. So what do we have? Point P is the same point here, and then which is 3, 3, right? We know that already, is it? Yeah, 3 and y equals 3. All right. And then passes through point P and the center C1. What does that mean? Oh, the center of C1. Okay. Right. So the second circle might look something like that. Yeah? Passing through point P and the center. Okay, just get a rough idea first. The center of C2 lies on the line joining P and the center C1. Ooh, okay. So the line joining P and the center of C1. So it might look something like this. It should be inside. I mean, it could be inside. Could it be outside? No. Yeah, so that's the only way, I think. That's the only way, right? Okay, so that's the only way to put C2 there. C1 is the bigger one. Find the equation of C2. So, yeah, that's not too bad. We're going to do it. So, the center should be the midpoint between P and the center of C1, right? So, the center of C1 was what again? 3 minus 2. So, the center of C2 then would be still 3, and then 3 plus minus 2 divided by 2 would be 1 over 2, right? Yeah? What about the radius? Well, just half the radius of the C1 circle. So the radius of C1 is what? 25. Yeah, so 25 is, 5. Yeah, 5. This is 5, so that means this is just 5 over 2. Okay, and then we plug into the equation. Easy peasy now. So x minus h plus y minus k equals that squared. All right. I think I'm okay with that, except if I want to multiply everything by 4. Let's see. If I multiply everything by 4, yeah, I could make it look a little better there. But I don't think I need to. I'm just going to stick with that, actually. Because they don't specify any preference of the final form there. So this is already fine. Yeah. Okay. Number 6. The function f is defined by fx equals that, where x greater than 5 over 2. The function g is defined by gx equals that for x in real numbers. Find the domain of the composite function g of f of x, right? So, the domain of the composite function is the range of the inner function, right? So if I write g of x like this, it would be maybe clearer to write it like g of fx like that. I mean, only a little bit different there. But, I mean, let's take a normal function fx here. You know that whatever you put inside the brackets here, it's called domain. Yeah, so in this normal notation of fx, x will be the domain. So it's like whatever you see, you can take the inside thing here, domain. So that means this whole thing is the domain of the composite function, right? That's the domain there. But fx itself, right? If you just write fx, naturally, it means a range of fx. So we need to find the range, we need to find the range of f. And that will be the domain of the composite function. Okay? Wait, actually, no, that would be the domain of g. Sorry. The domain of the composite function there would just be the domain of the fx. Right. Yeah. Sorry. So the domain of the composite function. I was saying that because I thought, I was gonna find the range of composite function, and probably it asks later on. Maybe not, but okay. Let's stick to A first. Yeah. So the domain of the composite GF here is just the domain of the inner function. Yeah, it's the domain of the inner function. So it's just, yeah, we take the domain of f there, which is just x greater than 5/2, basically. Okay, don't know why it's 2 marks. Okay, maybe too easy for 2 marks. And then find the expression for g of f of x. All right, so we're gonna put the whole fx inside the x of the g. So this is just e to the whole fx there, ln 2x minus 5 times 3 here in the front as well, plus 1. Now, if we put the 3 to be the power of the argument there, just using a log property there, we're gonna get, now we can use this property if you don't know. So when we have something to the power of log the same base there and x, this is x. But e is the same as, ln is the same as log base e, right? So this is anything, then it will have that thing there, down here. Right? So you need to know that natural log is just log base e. Okay, so I'm just going to pull the whole thing down, as in this whole thing. And then plus 1. And that is simplest form. I mean, or it's already nice to write like that, but do I need to expand? Yeah, okay, I'm going to expand. So 8x cubed minus 3 times 2x squared times 5 plus 3 times 2x times 25, and then out of space, and then minus 125, that's minus 5 cubed, and then plus 1. So just simplifying, 8x to the 3 plus minus, this is 4 times 520, 60x squared, and then that is 150x, and then minus 124, just simplifying the two numbers there. Okay, I'm gonna leave it at that, yeah, and move on to the next bit, which is probably more interesting. Find g of f inverse of x. Ooh, what is that? Okay, right. Okay, so it's just the inverse of this guy right here, because the g of f there is just one function. So if you look at this composite function as one single function using, say, a combined letter gf, and then they put gf together in the brackets, you see that. So that means we're going to find the inverse of this guy, right? And yeah, we're going to find the inverse of that. So we're going to put, this is y first, right? We're going to do x equals and then we change x to y because we want to find the inverse of that composite function above. So I do x minus 1, okay, yeah, and then cube root equals 2y minus 5. So y as a subject equals cube root of x minus 1 plus 5 divided by 2. Okay, so that's my inverse of the composite function there, just writing according to that and putting everything into the form like that. And we're gonna state the domain as well. So the domain of this function is the range of this guy. The range of this guy, yeah, is the range of the composite function, and we talked about that. To find the range of this composite function, you need to know the range of f and put it as the domain of G. Okay, so here we find the range of, what was it, GF first. So the range of f is, yeah, what is the range of f? So first we find the range of f here. The range of f is, well, that's a log, right? A natural log, and it's a ln 2x minus 5. So that's like shifting the ln to the right by 2.5. So it's real number because it's going to look like this. So the fx will look like this with the asymptote x equals 5 over 2, right? So this is all real numbers for the range. So the range of f is all real numbers. Yeah? Like that. And that means if we use all real numbers as the domain of G, yeah, we use this as the domain of G, which is already specified in the Gx already, yeah. So this is basically the range of composite function will be the same range as the range of G, right? And we can try plot the graph there to see. So e to the something x is going to give you that, but then you have a plus 1 there, so it's going to shift a little up, yeah, and that is the asymptote. So this is just basically the range of G is just y greater than 1. And that is the range of the composite function. Okay, so the range of the composite function is just y greater than 1. Well, that happens to be the domain then of the inverse. That's why we are finding this, right? That's going to be the domain of this. All right, I'm going to shrink this down because it's just the scratch there. Some working. So this is, the domain is x greater than 1 instead, right? That's it. Okay, that's the domain. Number 7. Show that integrating that gives that. Okay, yeah, I'm a big fan of DI method because they allow you to use that. Okay, so we're going to use DI method. And for those of you who don't know, well, you got to stick around here because it's faster. Otherwise, you're going to have to do by parts integration twice. And that can be a problem when you are not good at checking your own mistake because there's going to be quite a lot of minus signs, right? So stick around. I'm just going to write this first. And then I'm going to do a table. DI method is a tabular method. Yeah, and they do check for the table. So you want to write D here and the I here. D is just differentiate. I is integrate. Easy. So what goes into the D? Well, think about it. I mean, if you do normal by parts, you would have put this as a U, right? So that will go to the D. And the other one is just the I. So we don't do dv here. We just put the whole thing in, right? The first step. And note that DI method only works well when the U will differentiate to 0. So if you keep differentiating the U, so we get 2x first for the first time differentiation, The second time you get 2, right? Keep differentiating it. And then the last time you get 0. Differentiating 2 gets 0. So here is where DI method should work pretty well when you differentiate the 0. Okay? Now, what to do with the other column? Well, you integrate. You keep integrating e to the 2x, so you get 1 over 2 e to the 2x. It's not 2 e to the 2x. Be careful, you need to divide using the reverse chain rule. You keep doing the same thing, so you integrate this guy again. So that's going to be e to the 2x, easy, and 1 over 4 instead, now because you have another dividing 2 there. And then the last time, again, e to the 2x, 1 over 8, like that. Yeah? And then you go plus, minus, plus, minus. All right? And then what you need to do is to get the diagonal product here, here, and also here. So you get 3 products, considering the sign in the first column there. For example, if you multiply these two, it would be 1 over 2x squared, yeah, e to the 2x, right? But because there is a positive sign, so the sign is fine, we don't need to flip. Just keep the sign here, as is. And then the next diagonal product would be that. So what is that? It's 2 times 1 over 4, we get a half, so it's a half also. X e to the 2x. Now because there is a minus sign here according to the DI method technique, we put a minus sign here. Or if there was already a minus sign, then you would have to, flip the sign, make it positive instead. And then the last diagonal product is just 2 times that. So it is 1 over 4 e to the 2x. And this is positive, we don't need to change anything. And then you add them up with a plus c, right? So that will become, if we order in terms of the degree there, yeah, they don't need to, okay, just going to put that. And then I already got it. Everything is just as required, right? The same. That's it. It's going to overcome all the hassle of having to integrate by parts multiple times. And it's a really big bonus if it's x cubed. It could be, who knows? They might do that to you, right? Hence find the exact value. All right, so the exact value then for part B, we just use the bounds basically. That's not hard. So we're just going to do, just going to need more space there. Yeah. I'm going to have to write everything maybe. But we ignore the c because we don't need that when we do definite integration. 0 to 1. Okay. So I'm going to focus on that. So when you sub all the 1 in, you get a half e to the 2 for the first term. And then the second term is minus a half e to the 2 as well. And the third term is a quarter e to the 2. You subbing 0 in, the first 2 terms disappear. You are left with only the third term. And we put minus here. The third term becomes 1 over 4 because e to the 0 is 1. And the first 2 cancel there. We only get 1 over 4 e to the 2 minus 1. Nice. Nice looking. Okay. Yeah, I think I'm happy with that. Number 8. Vectors then. The points A, B, C, and D have position vectors. Ooh, we have 4 vectors. All right. Show that A, B, C, D is a trapezium, but not a parallelogram. Interesting. So we want to show that this is a trapezium. Trapezium would look like one of these. So the main requirement for the quadrilateral to be called a trapezium is that it has to have 2 parallel sides. Okay? So, okay. Interesting. Okay. So we need to pair up some 2 vectors. And then, so we need to find relative vectors. So for example, if we assume that it's going to go like this, so we're going to find that AB would have to be parallel to, say, DC. And we will have to be able to write that AB is just a multiple, right? A vector AB should be found as a multiple of vector DC. So it requires that we find some relative vectors in this shape. Let me just sip some water. Okay. So let's see. If I do B minus A, this will be AB, right? So I'm going to get 2I minus J plus 2K, yeah? All right. And if I do, I'm just guessing, right? DC, so that would just be C minus D, right? So that's 4I minus 2J minus 4K. Does that work? Doesn't look like it does. Yeah, it doesn't work there because we can't find a common multiple from one vector to the other. Not really. Not really. So we can do something else. So let's assume AD and BC instead because we already gone for the one pair, so we should pick the opposite pair. Yeah. So that should be AD and BC. So we do AD is D minus A. So D minus A is just 0I, just going to put 0 anyway, plus 4J minus 5K. AD and BC, right? Which is C minus B. So it's C minus B. It's 2I plus 3J minus K, right? Yeah. Can we do that? Doesn't seem like there is a multiple there. Okay, we're in trouble. Okay, so AB, or is it? No, it can't be AB. Wait, or these points are not in a cyclic manner. Maybe B is here, maybe I'm tricked here. And C is here and D is here, I don't know. So I'm going to try AC and BD then. AC and BD. But let me just check my work here again, yeah? Because I might make a mistake, might have made a mistake here. So D minus A. Oh, it is 3 instead. This is minus 4 minus minus K, so that's minus 3. But that doesn't make any difference because the C minus B, yeah, it doesn't have the I as 0, so probably doesn't work. We need to go to the alternative here, AC, so that's C minus A. And then C minus A, we get 4I, you just follow that. And then minus K. Wait, no, 1K, because minus minus. Yeah, I'm just checking. And then BD, D minus B, so D minus B, we get a minus 2I, okay? And then a plus 5J, this is not good, minus 5K. Okay, not good looking, not good looking, okay. Okay. No. I'm just doing some mental math here to run through the combinations. Right, okay, this is a bit tricky. Am I missing anything? A, B, B, C. Okay. I mean, I hate to have to draw this out, but that would be my last resort here. I mean, to draw out the all the vectors in 3D. Okay, that's going to be tricky, but bear with me. All right. Okay, so that's X and Y and Z. Okay. I'm going to try my best to do this. So A is 1, 2, minus 1. So 1, 2, 1, 2, minus 1. So it's the opposite way here. Yeah. So we can do something like this to, you know, locate all the coordinates correctly. So I'm creating my own box here to make the perspective like easier to see in 3D. And you also have behind the box there. Okay, so 1, 2 minus k is 1, 2 minus k, go to the right. Yeah, like that. Okay. Ooh, that's gonna be tricky. Okay, 1, 2 minus 1. How do we get minus 1 along the k there? So this is 1, 2, 3, 4. So that's 1, 2, 3, 4. So 1, 2 minus 1 should be around here. That's A. And then B, 3, 1, 3, 1, 1. So it's on the front plane there, just coming to the front. And then C is 5. Okay, 5 along the X. 4 up there. And then 0. Oh, okay, this is on the XY plane. Okay. And then 1, 6 minus 4. 1, 6 minus 4. So that's further at the back. It occurs to me that that is not a trapezium somehow. So B is, you know, going towards you. A is like going behind the XY plane. D is further at the back because it's like minus 4k there. And then C is somewhere on the XY plane. Something like that. So our best shot is actually to do AD and BC. Did we do that already? Okay, I'm going to do it again. A to D is D minus A. Like that. So it's 0, I plus 4J plus, yeah, we've done this, minus 3K. And then A and D and B and C, so BC is C minus B, so 2I, that's not right already. Yeah, because you can't get 0 to 2. So if A, D, and BC doesn't work, then how about AB and DC again? AB and DC. I think, yeah, okay. Let's try that again. AB, B minus A, 2I minus J, minus 2K, right? Yeah. Wait, what? K minus K, yeah, plus 2K. All right, just checking. All right, and then A and B, and then we have DC, so I'm just gonna guess DC here, C minus D, C minus D, so we have a 4I, and a minus 2J, and what? This one works? C minus D plus 4K? Okay. Why did I miss this? Did I miss it, you guys? Somewhere? Yeah, because you can now multiply AB by 2 to get to the other one. So DC is equal to 2 times AB. So that means DC is parallel to AB. All right, we're going to stick to that. Okay, now I proved that at least it's a trapezium. Now, to prove it that it's not a parallelogram, oh, we should have kept the other pair, right? So it's AB and DC. That means the other pair would be AD and BC. AD. So AD is D minus A equals 0I, D minus A plus 4J. I probably did something wrong with the arithmetics of the numbers there. And minus 4 minus minus 1 is a minus 3 minus 3K. That's AD. and then the other one would be BC. So BC is C minus B equals C minus B 2I plus 3J minus K. All right? And we can't really find any multiple here because you can't make 0 go to 2 by a multiple. So AD is not parallel to BC. Okay? Therefore, only one pair of two parallel sides. Therefore, ABCD, therefore, what is this shape? Is ADCB. Yeah. This shape, I'll just call this shape, is a trapezium, but not a parallelogram. Yeah. That's it. Oh, that took long. And I had to do the 3D drawing there. Painful. Find the area of the trapezium. Okay, so we got AB and DC parallel. AB and DC. At least I know what to do, right? I have got the shape there. AB and DC. So we need to find the perpendicular distance between these two, right? Okay. And also the parallel sides. Okay, this is a bit horrible. We need to find the two parallel sides, like the lengths and then the height, and then plug in the formula. How do we find the shortest distance between A and D? Hang on, let me think of it. Yeah, the shortest distance. Okay. Shortest distance, right? It's like this distance right here. Interesting. Okay. All right. We need to find a vector that is perpendicular to both AB and DC. Okay? So you haven't done dot product. Probably not. It's not in the syllabus, but would have been in the IAL syllabus. So maybe I'm not going to use that. Let's see if I got anything in the formula sheet. If I could use dot product, then it might be helpful. I don't have anything. Okay, so how do I find the height there? I could use the cosine rule, but that would be horrible for 4 marks. Yeah, you need to find all the lengths of, A, B, B, C, D, C, A, D, all of them. Horrible. And then AC. You need to find 5 lengths, and then use cosine rule to find the area. Cosine rule and then sine rule again, like the AB sine theta. But that would be too much work. I'm just thinking about the. Okay, hang on. We might be lucky if like a pair of legs are perpendicular already. So how do we prove perpendicular without dot product? Because you don't know dot product, guys. So I'm trying to be fair here. Okay. So if we found the length of BC, it looks like this might be a perpendicular to this, yeah, just from my, kind of sense here. So we need to find length AB first. I'm going to find that first. Wait, hang on. Yeah, AB. Yeah. So AB is just, we did AB, so 2 minus 1, 2. Square root of 4 plus 1 plus 4. So that's square root of 9, which is 3. and then we do BC, right? So BC equals square root of 4 plus 9 plus 1. I'm going to be quick here. Square root of 14. Yeah, that's BC. And then what? We should do AC. Have we done AC? We haven't got AC. So AC is equal to C minus A. So C minus A is 4I plus 2J plus K. C minus A. Yep. So modulus of C, which is the magnitude, is just 16 plus 4 plus 1, and that is root 21. So if we do a Pythagorean, it's not a right angle triangle because 9 plus 14 is not 21, assuming that AC would be the hypotenuse. Let's do the other pair. It's the AD and DC, okay? So this is much work. Okay, AD is, what was it again? 0, 4 minus 3. So, oh, that's easy. So that's 16 plus 9. This is 5. That's AD. And then what else? AD and DC. So DC we already have, it's here. 4, 2, 4. 4, 2, 4. Okay. So DC equals 4, 2, 4. Right? And what is that? It's 6. Okay. So 25 plus 36 is obviously not AD and DC. Is obviously not AC. Okay, I'm in trouble. I'm in deep trouble. That's not right. So we don't have a perpendicular height. Let me think a bit. No. Yeah. Too much work on the cosine and sine rule. I mean, that would be my last resort, but I'm not going to spend time doing that for the time being. So I'm going to maybe put a flag on this one and come back to it later. If we have time, yeah, probably have to be that tedious, right? But I'm going to skip it for now. Number 9. The first 3 terms of a geometric sequence are that and that and that, where k is a constant. Show that k satisfies the equation. Okay. So geometric. That means if we do r, which is the second term divided by the first term, it should be equal to the third term divided by the second term, like that. Right? And if we do cross multiply, you will see that we get this. Yeah? Just cross multiplying that. Yeah? So expanding, we get what? 4k squared minus 2 times 4 times 2 is 16k plus 16 equals k squared. 2k minus k is 1k and minus 2. So we have 3k squared minus 17k plus 18 equals 0. Alright, that's fine. That's good. Shouldn't be that hard. Okay, B, given the sequence is defined, that the sequence is defined and the common ratio R satisfy that, find the value of K. Okay, it's defined. What does that mean? Okay, so we just gonna solve that, I guess. So 18, 2 and 9, 9 and 2, no. 2 and 9 doesn't work. No. What about 18 and 1? No. What about 6 and 3? No. Oh, yes. 6 here and 3 here. Is it? No. Wait, what? No. None of them work. So seems like we need to find the use a calculator here I didn't make any mistakes, right? Okay. So yeah, you can also do that too, but we're gonna say that we use a formula anyway. So 3 and then minus 17 and then 18. Okay, so those are the two roots. At least they are real. Yeah. So it's just that, right? Yeah. So this is just k equals 17 plus minus square root 17 squared minus 4 times a times c divided all by 2 times a, and it will give you that. Okay, so that's just the values of k. Well, we only want one value, right? Okay, so we need to check r, the condition of r, because r, absolute r, needs to be less than 1. But if we plug into one of this, yeah, let's take the first one then. So 2k minus 4 over k minus 1. So if we try to get some sense of this, I'm going to go with a smaller value of k, which is negative, right? So I'm just going to go with the negative here, this one. Okay, anyway, just exit this mode first. And then I'm going to go answer. No, not yet. So minus root 73 and then plus 17 divided by 6, right? Store that as an answer and clear. And then we have 2 times k, which is the answer, minus 4, and then answer minus 1. That gives me greater than 1. So I picked the wrong one. Okay, I picked the wrong one. Right. Let me just go back. Can I go back? No, I can't go back. Okay, I'm going to do it again. Just now I picked the plus, so I'm going to pick... just now I picked the minus, so I'm going to pick the plus now, which is root 73 plus 17 over 6 equal. Store that as answer. Clear. And now we have 2 times answer minus 4 over answer minus 1. What? Okay, that also doesn't work either. We're in trouble again. Are we not? Because r needs to be less than 1, but not less than minus 1. We got both cases to be outside the range here. Okay. 2 k can be anything, so it's approaching 2. Oh, that's approaching 2. Doesn't make sense. This is not possible from the beginning because it tells me that r is greater than 2 here. I mean, looking at the irrational function, the rational linear function here, r is greater than 2 anyway, right? Can it be smaller than 2? If I try plug 0 in, I get 4. Yeah, that's wrong. There's a problem with this. Right. And you can't find sum to infinity if there is a problem with this. Okay. I'm going to skip this question. Yeah? Okay. Okay, number 10. The curve C has equation y equals that. Show that the equation of tangent to C at the point P where x equals 1 is that. Tangent to C at point where x equals 1. Okay, so we're just going to differentiate to find the gradient function. Differentiating the first time is just 3x squared minus 6x minus 5. Just differentiating, easy. And then we find the equation of tangent, sorry, the gradient of tangent. So just subbing in y x equals 1. Yeah, and that gives you 3 minus 6 minus 3 minus 8, right? So we're just going to do, we're going to find y as well. So y equals 1 cubed minus 3, 1 squared minus 5 times 1 plus 4. Just substituting x equals 1 into the original y function to get the y. And this is 1 minus 3 is minus 2 minus 7 and minus 3. Alright, so y minus y1 equals mx minus x1. This is just to form a linear function. Y minus the y will become a plus 3 there. And m is just, this is tangent, not normal, so it's minus 8. And x minus x1 is just already 1. Expanding everything, we get that. And then we put, yeah, so y equals minus 8x plus 5 as required. Okay? And then part B, the iterative formula that is used to find a root of that, just the root of the original function there. Starting with x0 equal 1.5, find the values of x1, x2, x3 to 4 decimal places. All right. Okay. So, yeah, we're just gonna use another calculator of mine, which is this one here, because it's doing a better job at that. So x1 equals, we're just gonna put x0 of 1.5 first, just some adds there, and then clear, and then what do? Cube root. Interesting. Oh, I see. Okay, so this is just rearranging. Right, okay. So cube root of 3 times answer squared. Let's shrink down a little bit. Plus 5 times answer minus 4. That's x1. Yeah? x2, well, we need 4 decimal places, right? So it's just that. x2, hitting enter again. Yeah. I mean, the first hit didn't work, yeah. So this is the second hit, rounded to 4 decimal places. And then x3 again. Ooh, 3.1960. Just out of interest, right? If I keep pressing, oh, okay, it does converge. Yeah, to 4, basically. All right. That's just part B. You don't need to write the substitution there, okay? Part C, the root found in B is alpha by considering a change of sign of x cubed, blah, 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 in a suitable interval. Yeah, it's about 4 point, yeah, it's correct to 4 decimal places. I made a mistake about this once in the other international A-level paper, so I'm not going to make it again. So we consider the interval to 4 decimal places, so it's going to be 3.99995. Yeah, just minus that by 0.00005, and then the other one is just adding that by this. So you go to the 5th decimal place to go 5 and minus 5, right? If you know what I mean. Yeah, because if you add this back by 0.00005, you're going to get the 4. So we do add by that and minus that to get the interval here, the range. Okay. and we're gonna put this into the which function? Considering change of sign. Okay, yeah, it's already telling us to do that function there. So this is just, okay, I'm just gonna write fx equals x cubed minus 3x squared minus 5x plus 4 here, and I'm gonna do that, just easier, yeah. And also that, yeah, to see a change of sign expectedly. So I'm gonna bring the other calculator there. So what do? We put 3.99995 first, 4 9s and 1 5 as an answer, clear. And then we do what? Answer cubed minus 3 times answer, was it squared? Yep. And then minus 5 times answer, and then plus 4. Okay, so that's minus 0.00094,950. Okay, I'm going to stop there. And then clear, we put 4.00005. Okay, you got to keep an eye on the calculator screen all the time to check if you press things correctly. I've seen mistakes all the time, calc error, where students put wrong things into the calculator that they didn't intend. Yeah. Okay, but I intend that. Okay, wait, what? 4.00005 equal, clear. Okay, and then what again? Answer cubed minus 3 times answer squared. Wait, no, squared. Yeah. And then minus 5 answer. Let's put times answer plus 4. That is a positive indeed. And very close to, the magnitude are so close. So this is indicating that the root is quite accurate. I mean, to 4 decimal places, of course. So therefore, if x has a change of sign while being continuous in the interval that, therefore a root alpha equals 4.0000 for dp. Yeah, that's it. Gonna leave it at that. Okay, 11. We have quite some time, so I hope we can get back to that vector question. The value of a car v pounds t years after it was bought is modeled by the equation that where a and k are positive constants. The car was bought for that. After 2 years, value is that. Find the value of a. So a is just the initial value. So we just put t equals 0, right? So that goes to 1. The value, the car was bought for that. So yeah, so v equals a. So a equals 25,000 pounds. Okay. Yeah. That's part A. Part B, show that k equals 1/2 ln of that. So we're going to use the other equation when t equals 2. So it's 18,000 equals 25,000 e to the minus k times 2, right? So solving for k, we get what? So all the zeros cancel. We get ln 18 over 25. And then this is minus 2k. So I'm just checking there. So k equals minus 1 over 2 ln of 18 over 25. If you put the minus into, into the argument there, it's going to flip the fraction. So you can cancel the minus and then just do this. Yeah, just put it to the power of minus 1 and then it flips the fraction. So that's just our k, right? Part C. Just going to go to the next page. Find the value of the car after 5 years. Oh, that's not too bad. V5 equals A is again, what was it? 25,000 e to the, I'm just going to do minus k times 5 for the time being, right? And you can put the whole thing in there, but yeah, you can use a calculator. Should we use a calculator? To the nearest pound, yeah. So 1/2 times, no, 25,000 times e to the power of minus, what is that? 0.5 times ln, yeah, so 25/18, right? Because there's a minus sign there, but k was that. Yeah, I think I'm happy with that. And then don't forget to times 5 the whole thing here, right? So that is just what? That. Nearest pound, I'm just going to do that first. So nearest pound is 10,997. Nearest pounds. Yep. Okay. So that is just it for C. For D, find the rate at which the value of the car is decreasing after 5 years, giving your answer to the nearest pound per year. The rate at which the value of the car is decreasing after 5 years. So we're going to differentiate. The value of the car is V, so the rate of change is dV by dt. Yeah? So this is just, if you look at the A and the K as letters first, so we're going to get minus AK, just putting the minus K down, right? So it becomes a minus, and then e to the minus kt. You don't need to write too much. I'm just differentiating it first. And then we want after 5 years, right? Okay, so dv by dt at t equals 5 would be minus a k e to the, putting t as 5, so 5k. Yeah? So a equals 25,000 again, right? And k equals just that again. So we get dv by dt equals, and sub in. All right. So minus 25,000 times, I want to put ln, like a half times ln, no, that's e, ln of 25/18 as an answer first, because we do 2 of the k's there. Yeah, that's our k value, right? And then I store that. And then I do 25,000. Oh, also a minus sign, yeah, a minus sign, yeah. Times the answer, which is the k, times e to the minus 5 times k, which is the answer. So that's it. So that is a negative 1,806 to the nearest pound, so 0.267, blah, blah, blah. So this is negative 1,806, right? So the decreasing rate is, we summarize here, decrease at the rate of 1,806 pounds per year. Just summarize that, because we get a negative sign and that indicates a decrease, not an increase, right? Okay, so I'm done with number 11. Number 12, we got 15 questions with about 37 minutes. A right circular cone has a base radius r and slant height l. The cone is such that r plus l equals k, where k is a constant. Okay, right circular cone, like that, right? So this is r, this is h and l. Okay, wait, k is a r and slant height l and h, yeah. So r plus l, we are given here, equals k, where k is a constant. show that the volume V of the cone is given by that. All right, so volume of the cone is a third pi r squared h. But we don't have an h here in A, like they don't want an h, so we need to get rid of the h. So we can do a Pythagoras there. H equals square root of L squared plus R squared. No, minus, because it's L is the hypotenuse. Okay, seems like they don't want the L either, so we're going to get rid of the L by using this relationship. So L itself is just K minus R, yeah? So that's K minus R squared minus R squared. All right, so this is H equals K squared minus 2KR plus R squared minus R squared. The R squared cancel. We get what it wants, K squared plus 2KR. So therefore, this is a third, pi r squared square root of that. Alrighty, as required. That's part A. Part B. Given that k equals 12, does it make sense? Yeah. Use calculus to find the maximum volume of the cone. Okay, so seems like the only variable here in the volume formula is r, because k is a constant. That means when we want to find the maximum of a function, we differentiate it respect to the only variable, which is r. Okay? And put it to 0, of course. So differentiate it first, what do we get? That is a product rule. Oh, this is nasty. Okay, because we have a product of this function and this function right here. So you got to know that. So we got to differentiate d by dr of that whole thing. I'm going to write like this first. You know what? I'm going to put pi over 3 outside first and do d by dr of r squared times k squared minus 2kr to the power of a half. Yeah, just easier to look like that. Okay. Next page, just to make this go up a little bit. So that's pi over 3 in brackets. Yeah, u dv. So u dv is a half, and then the power subtract by 1, and then a chain rule there. A chain rule because k is a constant, so differentiate k squared goes to 0. And then differentiating minus 2kr is just going to be minus 2k, so we times minus 2k here. Okay, and then we have the other term, I just did u dv, so this is v du plus v, which is the second term, du is just 2r. So that's it. That's v du. All right, and now we put this to 0, right? Because we want to find the maximum. Yeah, I'm going to deal with k later. I don't need to now. So the pi over 3 can cancel, right? So 0 equal. Let's simplify everything inside. So we're going to get a minus here because this is a minus 2 and a 2, so they cancel. But remaining is the minus. Okay, so minus kr squared with that brackets there. And then a plus here, 2r, doesn't have, cannot simplify here, just that. So I can move the negative term to the other side so that it's easier to look at. Like that. Now it seems like if I divide across by this guy, it's going to cancel. So I'm going to write divide across by that. Yeah, I'm going to get, so the left side will simplify, so I get kr squared like that, and then 2r. So if you divide this whole thing into this, the power, they are the same base, right? And then the power is then a half minus minus a half. So they will become one whole. Sounds good, right? So that is just that. Yeah? Okay? We can cancel the k there, because this got k, right? So cancel 1k, we have r squared equals 2r. Now expanding 2r inside, we get 2rk minus 4r squared. Yeah, that's it. Yeah? So k is 12. We solve for r, right? And this is somewhat a little quadratic here. So 5r squared equals 2 times r times, what is k again? 12, yeah? So we got r. R is then equal to 24 over 5. Ooh, yeah. All right. But we want the maximum volume. So we need to sub this in to the R, to the volume formula. So volume is then, subbing that in, well, K being 12 and R being that, right? 12 squared minus 2 times R times K, like that. Okay? So what is this? Okay, answer in terms of pi. See the square root term first, in case things go wrong there. I mean, we don't want that, do we? I mean, you know what I mean? Like negative in the root. That's the last thing we want. Okay, it's not that. All right, so we are fine with that. Yeah, and then outside. So this is, that's a horrible number. Okay, so this is just 12 root 5 over 5. 24 squared over 5 squared is just that. So 3 can cancel once with that, I think. So it's 192. Yeah. And then I'm just going to simplify all that in terms of pi, because it seems like it wants an exact value, right? So this is, okay, 192 times 12, yeah, over 25 times 5 is 125, and then root 5, and then pi. That's it, right? Checking everything? Yep. That's the maximum volume. I think I'm going to have to be happy with that for the time being, otherwise I'll run out of time. So 13. Prove by contradiction that if n squared plus 3 is odd, then n is even. Alright, so we assume, yeah, if n squared plus 3 is odd, we just put the negation at the second part. Then n is odd, that's it. From the second part being even, we change it to an odd. That's it. They condone that. Easy. Okay, so we're going to start usually from a simpler term, which is n rather than n squared plus 3. So n is odd, so this is an easy proof. You just put it to 2k plus 1, where k is an integer, a positive integer. Yeah? Okay. Now n squared plus 3 is just 2k plus 1 cube, sorry. Oh, squared, but I wrote cube. See, when you keep writing in the working, you got to look back all the time. Like, you got to, yeah, you need practice on this, if you know what I mean. Like, you keep writing forward, but sometimes you need attention backwards. You know, you need to check a bit what you've written, basically. Okay? So I can show you. Okay, so I'm going to write, okay, so I just happen to know the cubic expansion for this. So it's 8k cubed. Wait, it's not expansion. You see, I look back in the power again, so I realize that it's not a cube. I wrote a cube. It's not actually a cube, it's a square. So it's just 4k squared plus 2 times 2k times 1 is 4k. See, I look in my handwriting and I wrote 2, although I said 4. And then plus 1 and then plus 3 here. I checked. Okay, so that's just it there. And I double check my line again, see if I got everything right. Okay, and we're gonna pull 2 out here just to carry on with the steps. So we say that this is even, right? It's a multiple of 2. And this contradicts the assumption that n squared plus 3 is odd. Yeah? The assumption that n squared plus 3 is odd. Therefore, if n squared plus 3 is odd, then n is even. That's it. So we just copy paste the original statement. That's just the way to go. Now, number 14. A curve C is defined by the parametric equations that. Let me sip some water. Sorry. Find an expression for dy by dx in terms of t. All right. So just normal parametric. Part A, dy by dx equals dy by dt divided by dx by dt normally. Dy by dt, so we differentiate the sine 2x and the cos t. Sorry, sine 2t and cos t. So we get a cos 2t first and then a chain rule, so you pull 2 out. And then differentiating the cos t, you get a minus sine t, so that becomes a plus. Okay, divided by dx by dt. So differentiating the cos 2t, we get a minus sine 2t, but then the chain rule, so we get a 2 out here as well. Differentiating sine t, we get a cos t. That just looks like, the top and the bottom look opposite, except the minus sign there. Okay, and that's just done, isn't it? We can leave it at that. Okay? And then part B. Find the equation of the normal to the curve at point where t equals pi over 6. Yeah, that's fine. So we just find the gradient at t equals pi over 6. And then that will become the gradient of the tangent. We just flip and put a minus for the normal. Okay, so just do some trick terms here. So cos 2t will be 2 times pi over 6, so that's pi over 3. Cos pi over 3 is cos 60 degrees, so that's 1 over 2. So this is 1. Okay, I'm just going to do 2 times 1 over 2 plus sine t is sine 30. Yeah, sine 30 is 1 over 2 minus 2 times sine 2t again is sine 60, and that is root 3 over 2. Yeah? Okay, plus cos 30 is also root 3 over 2. So that becomes, the top bit becomes 3 halves. Alright? And the bottom bit becomes what? It's a minus root 3 and a plus half root 3 there. So it's a minus half root 3, yeah. Yeah. Okay, I think I'm happy with that. Yep. And then the 2 cancel, so we get minus root 3 for the tangent. That means the gradient of the normal would have to be 1 over root 3. Just flip and then put a minus sign. And then we haven't got x and y because we need to find the Cartesian form of the normal, right? So x equals, at t equals pi over 6, so that is just cos, 2 times pi over 6 plus sine pi over 6 there equals what? Okay, again, so cos of pi over 3 would be 1 over 2, and that is just also 1 over 2, so that's 1. And y would be sine of 2 times pi over 6 minus cos pi over 6. So that would be what? Sine of pi over 3 would be root 3 over 2. Cos pi over 6 is also root 3 over 2. So that's 0 for the y. Yeah? Let me just double check. Yeah, I think I'm happy with that. So y minus y1 equals mx minus x1. Y minus y1 being 0 equals m is 1 over root 3. X minus x1 is 1. Multiplying root 3, we get root 3y equals x minus 1. And yeah, I think we can put it any form we like. So I'm just going to go with x plus root 3y minus 1 equals 0. That is, oh, I made a mistake. I look back, so I see that this has to be minus. And that's it. Okay. All right. That's number 14. So number 15. I mean, if you check every time you write a line in the working, you probably don't have to come back and check everything. Unless you realize you make a mistake, then you should check everything again. But, I mean, effectively, if you check every line you write, check everything you write. Just like, it's called attention mechanism, right? Every time you write, you check back. Every time you write, you check back. You'll be fine. It's hard to make a mistake when you do that. It takes practice, but if you don't try, it's gonna be hard to do it. And silly mistakes will keep coming. Although I know how to do this, I still make silly mistakes. So if you guys are further away than that, then you know what I mean. You guys, might have already been frustrated about silly mistakes before. Everyone is, Last one. The rate of cooling of a liquid in a container is proportional to the difference between the temperature of the liquid, theta, and the ambient temperature, 15 degrees. Initially, the temperature of the liquid is 95. After 10 minutes, the temperature of the liquid is 55. Ooh, okay, what is this? The rate of cooling, okay, so I'm going to write dt by dt. This is the rate of cooling. Yeah, is the rate of change of temperature. But the temperature, they use theta here. Yeah, is proportional to the difference between the temperature of the liquid, theta. Oh, wait, hang on. And the ambient temperature. The rate of cooling of the container. All right. The rate of cooling of the liquid in the container. Yeah, okay. So it's d theta by dt equals proportional, right? So proportional is just a multiple of k times the difference between that and 15 with a minus sign, because it's cooling, so the temperature is decreasing. Yeah? Okay, and then we're gonna, solve it by using integration by separation of variables. So we separate the term first. I'm just gonna put that here and minus k dt here. Yeah? And then we integrate both sides. For that, we get ln theta minus 15. The other side, I get minus kt plus a c. Okay? And then they give you initial condition. We need to solve this completely. K and c must be known. So initially, when t equals 0, you get theta equals 95. So that's going to be ln of 95 minus 15 equals minus, this is 0, plus c. So c is ln of 80. Yeah, ln 80. And then the second condition after 10 minutes, well, time is in minutes, I hope. Yeah, time is in minutes. So after 10 minutes, temperature is 55, right? So I'm just going to write that. So ln of 55 minus 15 equals minus k times 10 plus ln 80. Yeah? And we're going to solve for k. So ln 40 minus ln 80 divided by minus 10 would be equal to k. Just solving that, yeah? So that's basically ln, if you put the minus on top here, it's going to swap the term. So I have ln 80 minus ln 40, which turns to this using a log property, divided by 10 equals k. Yeah. So 80 over 40 is 2. So that's 1 over 10 ln 2. Right? Yeah. And then we put everything back in. So theta equals, wait, no, not yet. Start from the ln form first. So ln theta minus 15. And then equals 1 over 10 ln. Oh, I don't need to. Oh, okay. Okay. We just needed to find c here. We didn't need to find k yet. Sorry, I'm just going to move everything down here. Because the form includes the k there. So just going to paste that here first. Because they ask k later. You see that? So that happens in the exam and you need to adapt to it. Right? Okay, so I'm just going to put ln theta minus 15 here equals minus kt plus ln 80. Okay? Yeah, and we're going to solve, make theta the subject there. But before that, we need to move everything. So I'm guessing this is fine because theta will be greater than 15 anyway, right? And we have ln minus ln 80 here minus kt. So that is just ln theta minus 15 divided by 80 equal minus kt. Yeah. Now you're doing the reverse thing. You put e on the other side, and the left side will just be this, equals e to the minus kt. If we multiply 80 on both sides and add 15, we're going to get what they want there, which is this. Yeah? Alright, so that's as required. Now, b, I just did b already. So that is just 0.1 times ln 2. 0.0969, 3 significant figures, so that's it. Yeah? Okay. As for B, what? 4 marks? Okay, good. Find the temperature of the liquid after 25 minutes. So we're just going to find theta when t equals 25. Alright, so theta at t equals 25 is equal to, we're just going to use that equation there. Right? E to the power of minus k times 25. And I'm going to, use this in a calculator, right? So that's equal. Put that as an answer first. Yeah. And then clear 15 plus 80 times e to the power of minus k times 25. So that's 29. Blah, blah, blah. And that is, find a temperature. So I'm going to round it to 2 significant figures. 29, 2 sig figs. 29 degrees Celsius. Yeah, should be fine. Okay, so that is the end of all questions. Just 1 second. And we will mark the, no, not yet. I need to go back, so I still have time. So I need to go back. And there is one question that doesn't make sense here. Yeah, so let's see. I might be wrong. So let's check number 9. Because I stopped here somewhere. Because although I get to show what it wants in A, but then it says that K, find the solution to K here. And we got to find the ones that work, because when we sub into to find the R, none of them work. So let me just check the quadratic answer again. Yeah. So this is quadratic answer. What's that? So we're going to do, yeah, I can just look at the question there. So this is 3. Oh, that's already on the screen. 3 minus 17, 18. And that gives me that. or that. Now if I put either of them into the common ratio equation, none of them work, right? None of them work. Yeah. Wait, if I put to the second one, what happens? Wait, okay, that's weird. Let me try put in the second one. This one here. Okay, so I'm gonna use that. Interesting. Let's try that. So root 73 plus 17 divided by 6. Okay, keep that. And then answer plus 2. 2 times answer minus 4. Okay, so we expect R to have the magnitude of less than 1, but it's not. Again, start over. Minus root 73 plus 17 divided by 6, store as an answer. And then we do answer plus 2 divided by 2 times answer minus 4. Yeah. That's still not having a modulus of less than 1. So question B and C here fail miserably. So yeah, I guess I'm not going to put... So I'm going to fix this question when I put in the corrected version, maybe. Make it more proper. So I gotta say question 9 here is kind of like broken. Let's go back to the vector question, the problem that we have left here with 10 minutes of time. Okay, so because I was out of options to do, like it asked you to calculate the trapezium. And I had to draw this out because I didn't see the 2 parallel sides at first. I mean, I didn't get it first. So I'm just trying to think a bit, yeah. So I'm gonna be quiet a little bit. We have already proven that there is no perpendicular angle, there's no 90-degree angle between any 2 legs in the trapezium, right? Yeah, already proven here. So AB and BC, and then when you add up the Pythagorean there, it's not AC, except I did AC wrong, which I didn't. 16, 4, and 1, so that was 21. That should be right. So AB and BC is not perpendicular. Okay. But you know, I got some time, so it seems like I'm gonna have to use sine and cosine rule, right? So if I do a cosine rule of this triangle, I'm gonna get that angle, and I could find the area of this. If I do a cosine rule for this, I get this angle. I'm gonna use that angle to find the area of that and add them up. That's a horrible method. It's a very tedious method, but probably the last way if you don't know dot product or cross product, because that's like further math actually. All right, so we're gonna do ABC. So angle, what is the angle? Angle B, right, at B. So cos B would be equal to square root I'm just using cosine rule here, guys. Let me just check. Okay. Cosine rule, so yeah, so it's the two sides squares adding up, AB and BC. So AB is 3 squared, BC is root 14 squared, so 14. So it's going to write 9 and 14 here, yeah? Minus, no, not minus. Going to have to minus the opposite side, which is AC, and AC is 21. And then all divided by, in the root here, oh, this is not in the root, sorry. It's just outside, yeah. Divided by, what is it? I'm just doing the math inside my head right now. Yeah, it's 2 times the B and the C. So that would be cos B. So 23 minus 21 is 2 over 6 root 14. So that's 1 over 3 root 14. So sine B is just 1 minus cos squared B in the square root. So that's square root of 1 minus 1 over 9 times 14 is 126 here. Horrible. That is just 125 over 126. Yeah. Okay, I need a page here. I'm just going to add a page. And then we do 1/2 AB times BC times sine beta here. Yeah, sine B. So area of ABC is 1/2 times sine, yeah, times AB, which is 3, times root 14, which is the other one. Okay, yeah, gonna keep it at that first, and then I'm gonna add everything on the last step, yeah. And the other one is triangle ADC, right? So I'm going to do cos what? Cos the other angle, which is cos D, right? So cos D is, again, AD squared plus DC squared, AD squared, AD squared, AD squared is 25 plus, the other one is what? DC squared, so DC is 36 minus, the diagonal should be the same, which is 21, divided by 2 times 5 times 6, yeah. Okay, and then we have what? 25 plus 36 plus 21, 40, and then that's just 4, that's 2 over 3. Okay, that means sine D is square root of 1 minus 4 over 9, so that's square root of 5 over 9. So triangle, area of triangle ADC is equal to 1/2 times the sine times the two legs, which are 5 and 6, right? Yeah. And then area of trapezium ABCD then equals to area of ABC plus area of ADC, right? Yeah. So that's just adding them up. I'm just going to do 1/2 times square root of 125 over, over 126, and then times 3 times root 14. Yeah, not a nice number, guys. Plus 1/2 times square root 5 over 9 times 5 times 6. All right. So 16.8. There. I'm just going to do 7, 7, blah, 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 and 16.8. That's my answer. And I'm just out of time because it's about 2 hours. So, yeah, already went back to that one. And nothing else seems that wrong. Just that geometric sequence question there. The only one. And also this one. Yeah, it's just the flop there in terms of the question. So I'm going to stop the timer and I'm going to mark the paper. Okay, so this is the AI generated mark scheme, and I also mentioned about the question 1 and question 9 as well, that they may be flawed. So let's mark the paper, yeah, from the first question to the last together. All right, so first one, yeah, this one is probably flawed. We get, yeah, so that's one A is right, -2 and 4. -2 is a factor, so I did try divide them here, and then correct quadratic there. Yeah, x equals 2 is the only factor, no other real roots, right? So that's just the the change of the question there. So in the corrected version, I'll just change the question as well so that you guys can do it. All right. So question 2, the expanded form. Yeah, I got it. And then B is one. Yeah, this one we were able to prove that, and that's fine. Number 3. Yeah, I was able to prove that, and then solve for the roots. So yeah, I got the 3 over 4 pi and 7 over 4 pi. And then what's the other 2 roots? Okay. Yeah, okay, these 2. Yeah. So that's fine. They didn't say the 4 or 3 significant figures. I just went for 3. Yeah, so anyway, that should be fine. Yep. Number 4, wait, hang on. Yeah, so there are 4 roots. Yeah. Number 4, okay, so this is first principle of differentiation. Substituting that, yeah, subbing the 0 in, yeah, that's fine. Number 5, I equals 5 and 3 minus 2. And then x equals 3, yeah, that's fine. Point P is 3, 3. And then center C1 is 3 minus 2, so this is, yeah, I got that, fine. Circle equation of the other one. Number 6, yeah, x greater than 5 over 2 here, I got the 2 marks there. And for B, find the expanded form. Yeah, could have got that mark from there, but it's fine. I mean, yeah, got it there. And then C, yeah, this is just the expression there, so it's just here. And then the domain, yeah, x greater than 1. Good. Yeah, it took a while to explain that. I hope that's fine for you guys. Okay, so I applied DI method here, which should be allowed in the syllabus. So, and I proved that. That's fine. And then part B, wait, what? Oh, the integral. So it's a quarter e squared minus a quarter. Yeah, that's fine. Part B is the vector. Sorry, question 8 is the vector. So, yeah, I found everything, A, B, and D, C, yeah, did that. And then show that, yeah, 2 times each other. And then A, D, and B, C there as well. Yeah, they're not parallel. Yep, got that. Area of trapezium, A, B plus D, C. Really? And the height? Now they use cross product here, you see, guys. Cross product is not in the syllabus, I can assure you that. So this is too much. This is out of the syllabus. But let's see if I get the same value. I guess I don't. Yeah, I don't know if that is actually, let me try check that, if that's actually the same answer there. Yep, I got the same value. So I got it right with all that sweat. You know, it was worth it, guys. But I can assure you, they won't let you use cross product, and this is too much for vectors, right? So don't worry. Yeah. Okay, so I proved that, and again, this is not a valid geometric sequence. So B, yeah, so for the value of K, so I got two values there, but then C, you know, not valid. I mean, the question is not valid, so this is voided probably. And number 10, yeah, that's fine, that's required. B, 3 roots, let's see, that, and I got a different one. Okay, I think there's something wrong with the calculator. Okay, I think I'm gonna annotate the video, so yeah, I'm gonna question mark that first. And then for C, this is fine, just proving change of sign. Yeah, I think I picked the right bound there. Okay, and 11. So so 11 here, A, 25,000, B, yeah, I proved that. And then this is 10,997, yeah, nailed it. D, yeah, the decreasing rate, yeah. Number 12, yeah, I could prove the formula, and then dV by dr, right? I'm just going to look at the last answer, the final answer it gives me, which is kind of like that fraction right there. Yeah, I nailed it. This is the fraction. Like the AI seem to kind of like have a long working line here. Right, long working. Yeah, so I nailed it. This is the final answer there. And then 13. Okay, odd, and it turns out to be even, so contradicts, so that's fine, that's easy. This is easy contradiction proof. So you guys should be fine. And this is also easy parametric, right? So I'm gonna look at the final equation. That is also, ooh, hang on, that's a little different. I got this to be the same though, right? Yeah, that should be fine. So it's like multiplying by √3, I'm gonna get the same equation there. So that should be fine. Oh, forgot to mark A. So A is this. Yeah, everything is fine. And the last one, 15. Yeah, I got this fine, and then I was able to prove that that is the case. And then this is K equals that, right? 29.1. I just put 2 sig figs, so that's fine. Yeah. I mean, it didn't say how many sig figs, right? As you guys can see, I'm just going to show you the paper. Not this one. Hang on, which one? This one. Okay. Yeah. It doesn't say how many sig figs. Well, it did say for K, but it didn't say for the final temperature. So I think I'm going to be kind to myself there, because the question doesn't say, and I do brackets to sig figs. So guys, I hope that was fine. I didn't make much of a mistake anywhere for this one. I think I nailed it. But the mistaken questions, I will correct the paper to be a better version, so that you guys can, and also the mark scheme, so that you guys can have the practice there. Okay, so I hope that was all useful, and please don't forget to subscribe. Yeah, I give you all. Please just give me subscribe. Love you all, guys. See you in the next one. Bye.